Meta prompting, enhancing language models with task agnostic scaffolding. Today, guys, I want to share with you a new prompt template that I stumbled upon. I believe it is very useful, and also the way that the research paper is written and the comparison between the different types of prompts is very useful, and I hope you will find it interesting as well. So I stumbled upon this research paper. I will share the link to the research in the show notes. Basically, this is a meta prompt. This is how it looks like. You are a meta expert, an extremely clever expert with the unique ability to collaborate with multiple experts, such as expert problem solver, expert mathematician, expert essayist, etc., to tackle any task and solve any complex problems. Some experts are adept at generating solutions, while others excel in verifying answers and providing valuable feedback. Note that you also have special access to Expert Python, which has the unique ability to generate and execute Python code given natural language instructions. Expert Python is highly capable of crafting code to perform complex calculations when given clear and precise directions. You might therefore want to use it especially for computational tasks. As meta expert, your role is to oversee the communication between the expert, effectively using their skills to answer a given questions while applying your own critical thinking and verification abilities. To communicate with an expert, type its name, expert linguist or expert puzzle solver followed by a colon, and then provide a detailed instructions enclosed with triple quotes. For example, expert mathematician, triple quote, you are a mathematical expert specializing in the fields of geometry and algebra. Compute the Euclidean distance between the points minus 2 whatever, and ensure that your instructions are clear and unambiguous and include all necessary information within the triple quotes. You can also assign personas to the experts, interact with only one expert at a time, and break complex problem into smaller, solvable tasks if needed. Each interaction is treated as an isolated event, so include all relevant details in every call. If you or an expert finds a mistake in another expert solution, ask a new expert to review the details, compare both solutions, and give feedback. You can request an expert to redo their calculations or work using input from other experts. Keep in mind, let's break this. Keep in mind that all experts except yourself have no memory, therefore always provide complete information in your instructions when contacting them. Since expert can sometimes make errors, seek multiple opinions or independently verify the solution if uncertain. Before providing a final answer, always consult an expert for confirmation. Ideally, obtain or verify the final solution with two independent experts. However, aim to present your final answer within 15 rounds or fewer. Refrain from repeating the very same questions to experts. Examine the responses carefully and seek clarification if required, keeping in mind they don't recall past interactions. Present the final answer as follows. For multiple choice questions, select only one option. Each question has a unique answer, so analyze the provided information carefully to determine the most accurate and appropriate answer. Please present only one solution if you come across multiple options. Okay, that was pretty long. I'm not sure if many of you stayed with me, but I just wanted to show you this whole prompt so you'll have the context. And now let me show you how it compared to other prompts, and we will break down each type of prompting template that are currently available or people are using. So let's go here. Just let me cover the abstract. So basically they are saying that this approach transforms a single language model into a multifaceted conductor, adept at managing and integrating multiple independent large models queries. So it's kind of similar to having many agents. And by the way, Autogen specifically the Autogen team has something that kind of reminds me of this, which is called the auto build feature, which allows you to give a problem and then the auto build framework or auto build task is just generates all the relevant agents from scratch. I will show you in a moment what I mean by this. So these subtasks are then handled by distinct experts, instances of the same large language model, each operating under specific tailored instructions. Central to this process is the LLM itself and its role as the conductor, which ensures seamless communication and effective integration of the output from other expert models. It additionally employs its inherent critical thinking and robust verification process to refine and authenticate the end result. This collaborative prompting approach empowers a single large language model to simultaneously act as a comprehensive orchestrator and a panel of diverse experts, significantly enhancing its performance across a wide array of tasks. And I will show you afterwards the comparison. These are all the methods that were tested. A zero shot, I will show you in a moment. Okay, never mind. Let's move forward to the research paper. Basically, they compared. Okay, so the meta prompt basically breaks down complex tasks into smaller manageable pieces. It assigns each pieces to a specialized expert with a proper detailed natural language instructions, and it oversees the communication between the expert models, and it applies its own critical thinking, reasoning, and verification skills throughout the process. So imagine that it's like having one CEO agent, and the CEO agent gives tasks to sub agents. Let's say we have a copywriter, we have a senior copywriter, and we have a programmer, and we want to build a landing page. So we have the CEO and we have all the sub agents. Now, the cool thing about this is, in opposing to other solutions, when you create, let's say you create in Autogen or Crew AI, you create a team of agents, you create each agent or even sub agent, you give them a description. In this case, these descriptions are also generated dynamically by the algorithm or by the large language model. And they did a comparison over here of the different type of models currently available. So at the moment, there are a few types of prompting methods. So the standard prompting, this represents the most basic baseline wherein a LLM is asked to directly yield a response without any specific guiding input or output examples or any additional guiding instructions. So this is the most basic prompt. You just go to ChatGPT or any other LLM, OpenAI, Claude, and you ask for specific thing without providing any other information. We have the zero shot chain of thought prompting. So drawing inspiration from the chain of thought method that was presented in this research, the zero shot prompting approach simply appends, let think step by step by input to the input query, encouraging the model to have a more deliberative and iterative cognition before addressing the problem or task at hand. So let's say, again, we want to build a landing page. In this type of open, we will say, let's think step by step how to build a landing page. And usually this yields better results. The next type of prompting is using an expert prompting. So this prompting approach functions through a two-step process. It first crafts an expert identity tailored to align with the specific context of the input query, and it then integrates this generated expert profile into the input to generate a well-informed and authoritative response. In this case, we have two types of expert prompting. One is the static and one is the dynamic. The former uses a fixed and generic expert description, whereas the latter adaptively designs a new expert identity for each input query. So for example, let's say an expert prompting, we can say, you are an expert landing page designer. Please create code, a React based code for me with a landing page, for example. So this is the static, and the dynamic is you can ask the LLM first to propose a description of the expert, and then you generate the prompt specifically for that expert. There is another type of prompting, which is the multi-performance prompting, also known as a solo performance prompting. This method instructs a large language model to perform the following: propose a small ensemble of personas to address the specific task or problem at hand. So for example, if we want to build a landing page, we ask the LLM, which personas, which expert do we need in order to build a landing page? So it might propose a copywriter, back-end developer, front-end developer, branding expert, etc. Then we let these personas engage in a collective dialogue, collaborating and generating potential solutions, and they extend feedback between each other. And at the end, we synthesize all the available information and deliver a final response. So these are the different types of prompts method available these days. This is like the most advanced, and these are also ways you can also structure an agentic framework. You give agents different descriptions, or you use the auto build function, which basically you just provide the task and it generates the agents dynamically based on the task. Now, they took a few different tasks and they created a test, and this is the result. I'm not going to bore you. I don't know if boring you is the right definition, but I don't want to make this video too long, so I'm not going to share what exactly was each task about, but this is the comparison. So we have the task. We have 1, 2, 3, 4, 5, 6, 7, 8 tasks. This is the standard prompt. This is the chain of thought prompt, and this is the expert prompt. There was the static description, dynamic description, the multi-persona, which is the last method that I shared, and this is the meta prompt, which is the prompt that I shared with you here via the notepad, and it's also available here in the GitHub repository. And this is the prompt when you also mention in the actual prompt that you have ability to use a code interpreter, a Python code interpreter, and this is when you have this ability. And you can see the difference in the results that were yielded, and it's a huge difference. So for example, for the task of word sorting, when we compare between the meta prompt with the Python abilities, this was the score, and this was the score when we had just the basic prompting method, and this is the delta. You can see over here also there is a huge delta in some tasks between the meta prompt when using a Python, when mentioning the Python code interpreter, and when not mentioning the Python code interpreter. So as you can see, this is pretty huge. An average of 18 points between the most basic prompt and the most advanced prompt. And you can see it also yields better results when compared to other experts, like different, more advanced ways of prompting. Okay, so let's just read the overall performance. So the meta prompting approach, particularly when augmented with the Python interpreter, consistently outperforms conventional zero-shot prompting across various tasks. And they are now elaborating about when it was better. So they say our structured approach embodies the principle of the wisdom of the crowd, which posits that a collective opinion of a diverse set of critical thinkers often surpasses the insights of individual experts. And this is very interesting, just the way, I mean, this is very mind-opening with regards in terms of when you're building prompts and how to interact with large language models. By harnessing an ensemble of specialized experts models under the guidance of the meta model, each contributing from different angles of expertise, we achieve more accurate and reliable problem solving. Another thing that they mentioned here, and which I thought was pretty interesting, is the concept of fresh eyes. So in each step, in each iteration, they basically tell the LLM to view the problem from a fresh perspective. And this is basically the flow. So the meta model proposes consulting experts in mathematics. Let's say this is a problem of arithmetic expression. And the Python, it emphasizes the need for accuracy and adherence to constraints, suggesting the involvement of another expert for review if needed. Then an expert proposes a solution which a second expert identifies to be incorrect, and the meta model suggests writing a Python program to find a valid solution. A programming expert is consulted to write a program. Another programming expert identifies an error in the script, modifies it, and then executes the revised script. And then a mathematics expert is consulted to verify the solution output by the program. And after this verification, the meta model outputs the final answer. What else was interesting here? So here was a bit more data. So they mentioned here that when scenarios that the Python export is explicitly mentioned for code generation and execution, there is a noticeable preference for technical and computational expertise. So just mentioning the fact that you have the Python abilities makes the LLM use or trigger more use of code. So, for example, in Python programming puzzles, the meta model frequently utilizes the Python expert. In contrast, for meta prompting without a specific Python expert, the spectrum of experts employed is more diverse. So it seems like, based on what they're saying, once you mention the Python ability, the LLM is going to use by default more often code. So, and if you don't mention specifically the Python export, you're going to get a more diverse pool of experts. Also, the number of rounds taken to achieve results was faster when using the Python expert and in this solution, the meta prompting. So there are fewer limitations at the moment. First of all, this method requires way more tokens because you're using a lot of experts and you're using the LLM very frequently because you don't hard code any descriptions for the expert, and you're going back and forth like an agentic framework. You're using if you use many agents, so you're generating a lot of responses and you're doing a lot of queries, so basically more tokens. There are a few more limitations, but I don't want to make this video way longer. So in general, this is a simple yet powerful scaffolding technique that enhances the performance of large language models in task-agnostic manner. This approach leverages a language model to act as both a central conductor and a group of expert instances, thereby, I'm gonna read another one there, okay. So yeah, they are just showing how this method of prompting generates way better results. Let me show you the prompt for choosing an expert because I think this is also valuable, and then we will conclude the video. Let's see. Okay, so this is, by the way, how they are creating the prompting for a specific expert, and I think this is also useful for you if you're looking to write better prompts. So for each instruction, write a high quality description about the most capable and suitable agent to answer the instruction. In person perspective. So instruction, make a list of 5 possible effects of deforestation. Agent description, you are an environmental scientist with a specialization in the study of ecosystems and their interactions with human activity, blah, blah, blah. There is another example, identify a descriptive phrase for an eclipse. So you are an astronomer with a deep understanding of celestial events and phenomena. Don't know why you use words that are so difficult to pronounce. And they have another example here. Identify the parts of speech in the sentence. The dog barked at the postman, and the agent description is you are a linguist well versed in the study of language and its structures. So basically, in this prompt, they are sharing a few examples of an instruction and output. And afterwards, they have the instruction, which is the dynamic field of the question. Let's say we have a question, write a landing page, create a landing page for me. And the LLM is expected to write an agent description. So dynamically generating a description, perhaps in this case, it would be, you are an expert landing page designer, well versed in building sales funnel using JavaScript, and then just elaborate and just create a very detailed description dynamically. Okay, I hope you guys find this useful. It was pretty long, and a bit random, but for me it was very useful, first of all, to see the breakdown of the different types of prompting methods currently available. I mean, I knew all of them, but I didn't know their names, and I didn't know, like, to make this distinction between the static experts and the dynamic expert, stuff like this. I also think it is very useful if you're using agents to keep this type of prompts in mind, and also the fact that if you're able to generate many experts, if you don't care about tokens or costs, so if you're able to create many experts, many agents that are specifically great in a specific very small task, it would be very useful. By the way, it kind of reminds me of the economist. What was his name? The most famous economist, not Milton Friedman. What was the name of the economist who said that economy is progressing with specialists? Adam Smith, maybe. Let's see. This is because this is also important in terms. Okay, let's see. Okay, yeah, Adam Smith. Okay, the economist who emphasized the importance of specialization in economic progress is Adam Smith. Yeah, he talked about it in The Wealth of Nation, and he argues that the division of labor and specializations are key drivers of economic efficiency and growth. Okay, can you elaborate? This is important, so let's dive deep into this. Can you elaborate? Why is it key? This is how an unplanned video look like. Okay, let's make this larger. Okay. This is what I love about one of the things that I love about AI and LLMs, because this is all related to human beings. It's all philosophy, to be honest. So, Adam Smith's idea of specialization and division of labor is central to his history of economic growth. Here's a deeper look into why this concept is so crucial. So, increased productivity, skill improvement. When workers specialize in a specific task, they become more skilled and efficient at it. This leads to a higher productivity as they perform the task faster and with greater precision. Time saving. Specialization reduces the time spent switching between different tasks. Workers can focus on a single task without the need to constantly change tools or workstations. Innovation. Invention of better tools. Specialization often leads to development of new tools and techniques. Workers who focus on specific tasks are more likely to come up with innovation that makes their work easier and more efficient. Process improvement. Continuous focus on a single task allows workers to find better ways to perform it. Economic efficiency. So, comparative advantage. Specialization allows individuals and nations to focus on producing goods and services where they have comparative advantage. Okay, trade benefits. Never mind. Okay, it's a more philosophy, not related to LLMs. Market expansion, also not related to LLMs. Okay, I think that's pretty much it. So, division of labor based on Adam Smith is very important, and this is why I guess for us we should also strive to implement it within our automations or whenever we use agents. And specifically for this case, the meta prompting could be very useful. That's it for today, guys. I hope you find this video useful. If you did, please leave a comment in the comment section. Obviously, like. If you haven't subscribed, please do. And until next time, keep on automating.